The global aviation world was stunned. Newsrooms buzzed with disbelief as the story broke. Something unprecedented was unfolding in the skies. China's C919, once grounded by US sanctions and international skepticism, was airborne again, defying expectations and rewriting the rules of the game. But this time it soared with a new, homegrown engine, the CJ1000A, a technological marvel developed entirely within China's borders after years of relentless research and innovation. The engine's roar was more than just sound, it was a message to the world. China's aerospace ambitions could not be contained, and its engineers had achieved what many thought impossible. The world watched in awe as the C919 lifted off from Shanghai, no longer dependent on Western technology, but propelled by the determination and ingenuity of its own people. For years, the C919 had symbolized China's reliance on foreign engines, a reminder of the country's technological gap and the barriers it faced. The US believed that cutting off engine supplies would halt China's progress, using export controls as a strategic tool to maintain its dominance in the skies. Today, that belief was shattered. The C919's flight sent shockwaves through boardrooms and governments worldwide, forcing a re-evaluation of what was possible. This flight was more than a test, it was a geopolitical statement, a bold declaration that China was ready to compete on the world stage. Beijing celebrated with pride, state media framing the event as a national triumph and a turning point in the country's technological journey. The C919 was now a symbol of technological independence, a flying testament to China's ability to overcome adversity and innovate under pressure. The duopoly of Boeing and Airbus, long unchallenged, now faced a formidable new competitor rising from the east. The implications were immediate and far-reaching. Global supply chains, industry standards, and the aviation market itself were now in flux, as airlines and governments reconsidered their alliances. The C919's flight on December 20, 2025, marked not an end, but the start of a new era, one where the balance of power in aviation was shifting before our eyes. The race for dominance in the skies had a new contender, and the established giants could no longer take their positions for granted. The world's aviation order was no longer a duopoly. A new chapter was being written, with China's signature on every page. China had arrived, and the rules were changing. The nation's engineers, once students of the West, were now setting the pace for the future. The C919's ascent was the beginning of a far more competitive era, with new opportunities and challenges for the entire industry. The Dragon had taken flight, and the world would never be the same. The sky, once dominated by a few, now belonged to many, and the story was just beginning. The US saw China's rapid tech rise as a direct challenge to its global leadership, especially in high-stakes industries like aviation and advanced manufacturing. The C919, China's ambitious passenger jet designed to rival Boeing and Airbus, quickly became a symbol of this competition, and a target for US policymakers. Washington's plan was clear: cut off the jet's most vital part, the engine, by leveraging its control over key aviation technologies. The C919 relied on the LEAP 1C, a state-of-the-art engine produced by a US-French joint venture, making it vulnerable to export restrictions. By banning engine exports, the US aimed to halt China's progress, protect Boeing's market share, and send a message to other aspiring tech powers. This move was part of a broader, multi-pronged campaign to contain China's technological ambitions and maintain American dominance in critical sectors. The logic was simple. Without access to Western engines, the C919 would be grounded, unable to compete or even fly. US officials believed China lacked the expertise and experience to build a competitive jet engine anytime soon, giving the West a decisive advantage. This was a calculated risk in a new technological Cold War, where every move could shift the balance of power. The export ban was meant to force China back to the drawing board, delaying its progress by years, if not decades. The US thought it held the trump card, confident that its technological edge would keep China in check. But the strategy underestimated China's resolve and its willingness to invest heavily in overcoming obstacles. Instead of stalling, the ban ignited a new determination in Beijing, fueling massive investments in research and development. The US misjudged its rivals' capacity for rapid innovation and underestimated the speed at which China could mobilize resources. In the end, the containment plan would have consequences no one expected, reshaping the global tech landscape in ways still unfolding today. In Beijing, the engine ban sparked not despair, but resolve. The government framed it as foreign bullying, fueling national pride. The C919 became a patriotic symbol, uniting the country. China's leaders declared that core technologies must be homegrown. The CJ1000A engine project became a top priority. Scientists, engineers, and students were mobilized nationwide. Universities launched new aerospace programs. State-owned and private companies joined the effort. The media celebrated engineers as national heroes. The ban, meant to cripple, instead triggered a massive innovation drive. The psychological impact was profound. China saw the West as unwilling to accept it as an equal. The only path forward: build a parallel, independent system. The engine ban accelerated China's push for self-reliance in all critical sectors. The C919's struggle became a rallying cry for technological independence. The nation's response was swift, unified, and relentless. The ban didn't stop China, it made it unstoppable. The C919's biggest weakness was its reliance on foreign technology, a vulnerability that cast a long shadow over China's aviation ambitions. Critical components like engines, avionics, and flight systems were all sourced from Western suppliers, making the aircraft's success dependent on foreign expertise and goodwill. When the US imposed export bans, this vulnerability was laid bare for the world to see, sending shockwaves through China's aerospace industry. Overnight, the global supply chain transformed from a symbol of international cooperation into a leash, restricting China's progress and threatening the future of its flagship jet. Faced with this stark reality, China realized it had to master every step of the process, from sourcing raw materials to the final assembly of complex aircraft. Building a jet engine is one of humanity's toughest engineering feats, requiring precision, innovation, and years of relentless effort. China now faced the daunting challenge of replicating and eventually surpassing decades of Western progress in just a few short years, a race against time and technology. The Aero Engine Corporation of China, or AECC, became the epicenter of this national effort, rallying the country's brightest minds and resources. Teams of engineers reverse-engineered foreign components, innovated new designs, and built state-of-the-art testing facilities from the ground up. Setbacks were frequent and sometimes dramatic, but each failure brought valuable lessons, fueling determination and technical breakthroughs. The ultimate goal was not just to copy Western technology, but to create something even better, an engine that could stand proudly on the world stage. Gradually, the C919's Achilles heel was being transformed into a source of national pride and technological strength. China's relentless push for independence was reshaping its entire aviation industry, inspiring a new generation of engineers and innovators. The dream of a truly Chinese jet, built and powered by homegrown technology, was now closer than ever before. The lesson was clear: dependence on others was no longer an option for a nation determined to soar. With unwavering resolve, China was determined to control its own destiny in the skies, forging a new path for its future in aviation. China's response was a national mobilization on a wartime scale. The CJ1000A engine became a top-tier priority. The government built a domestic supply chain from scratch. Thousands of new suppliers were nurtured with state support. China recruited global aerospace talent and expanded university programs. A new generation of engineers was trained on Chinese systems. The result: rapid progress and technical breakthroughs. The CJ1000A went from blueprint to prototype at record speed. The C919, once a symbol of global cooperation, became a symbol of self-sufficiency. China wasn't just building an engine, it was building a new technological foundation. The Great Mobilization was reshaping the future of Chinese aviation. The C919's successful flight sent shockwaves through the aviation world. The Boeing-Airbus duopoly was suddenly threatened. A new market split loomed: Western jets versus China's COMAC. China's Belt and Road partners became natural customers for the C919. Airlines could face a world of incompatible fleets and rising costs. The seamless global travel system risked fragmentation. Supply chains, once global, now faced political and economic barriers. Companies scrambled to de-risk and relocate production. China built its own parallel supply chain. The aviation world was entering an era of division and higher costs. The C919's next challenge: global certification. Without FAA or EASA approval, it can't fly internationally. Certification is rigorous, technical, and now, deeply political. China's strategy: seek Western certification while building its own regulatory sphere. The CAAC is signing agreements to expand its influence. Airlines weigh safety, reliability, and resale value. Without global trust, the C919's reach is limited. COMAC must prove it can match Boeing and Airbus in support and safety. Winning trust outside China will be a long battle. The technical victory was just the beginning. The real test is convincing the world to fly Chinese. The C919's rise threatens Boeing and Airbus where it hurts most: China's market. Beijing can shift hundreds of orders to COMAC, cutting Western profits. This loss could slow innovation and weaken supply chains. US suppliers risk losing billions as China builds domestic alternatives. The duopoly's comfortable era is over. COMAC will use its home market to scale up and compete globally. Lower prices and growing reliability will attract new customers. The skies are now a battleground for three, not two. The US engine ban will be remembered as a turning point. Instead of halting China, it accelerated its rise. The policy unified China and spurred massive investment in innovation. The C919's journey is a lesson in unintended consequences. Attempts to block technology can backfire, creating stronger rivals. The aviation industry is now a new front in global competition. The era of seamless cooperation is ending, replaced by rival blocs. The C919's roar is a permanent reminder. Trying to suppress a rival can make it unstoppable. The world's skies are more competitive and more divided than ever. The Dragon's flight is just beginning. The echo of this moment will shape aviation for decades to come.